20,000 years. It sounds like an absurd amount of time. But the truth is, 20,000 years is longer than almost everything we call civilization. It's longer than all of recorded human history, longer than agriculture, longer than cities, longer than every empire that ever rose and fell. If you could travel 20,000 years into the past, you would not meet a farmer. You would not meet a king. You would not meet an engineer. You would meet hunters sitting beside a fire, looking at the stars and wondering what those lights above them really were. They had no idea that one day their descendants would split atoms, build computers, walk on the moon, and send machines beyond the edge of the solar system. To them, our world would look like magic. And perhaps that is the best way to think about the next 20,000 years. Because if humanity survives that long, our descendants may see us the same way. Primitive, temporary. People who still lived on only one planet. People who still depended entirely on one sky, one atmosphere, one fragile world. Because once humanity enters space permanently, the human story changes forever. Not in decades, not even in centuries, but over thousands of years. Space does not change people overnight. It changes them slowly, silently, generation after generation. Until one day the people living among the stars are no longer exactly the same as the people who left Earth. Imagine being born on Mars. You have heard about oceans. You have seen videos of forests. You know what rain is because your teachers explained it to you. But you have never experienced any of those things. You have never seen clouds drifting naturally across the sky. You have never smelled a forest after a storm. You have never watched waves crash onto a beach. Instead, you wake up underground. The ceiling above you is artificial. The light around you is artificial. The air you breathe is produced by machines. Outside your habitat is a frozen desert where temperatures can plunge below -60 degrees Celsius. The atmosphere is so thin that if you stepped outside without protection, you would lose consciousness in seconds. And yet, to you, this is normal. This is home. Earth is the strange place. Earth is the alien world. Because home is not defined by where your ancestors lived. Home is defined by where you are born. This single idea changes everything. Most people assume that if we colonize space, everyone will still feel connected to Earth. But history suggests otherwise. Human beings adapt incredibly quickly. The descendants of immigrants often feel more connected to the country where they were born than to the homeland of their ancestors. Now imagine that separation not over an ocean, but across millions of kilometers. Imagine being the 5th generation born on Mars. Earth would begin to feel less like home and more like mythology, a place your ancestors came from, a place you have never seen, a place with gravity so strong it would make your body ache, a place where people walk beneath an open sky without pressure suits, a place so different that it almost sounds fictional. And this transformation may happen faster than we expect, because the first challenge of living in space is not technology, it is biology. Human beings evolved under very specific conditions. One atmosphere, one gravity, one magnetic field, one day-night cycle. Every cell in your body expects these conditions. Your bones expect them. Your muscles expect them. Your immune system expects them. Take those conditions away, and the body immediately begins to change. Astronauts on the International Space Station lose bone density. Muscles shrink. Vision can change. Fluid shifts toward the head. The body begins behaving differently after only a few months. Now, imagine generations. Imagine children growing up under only 38% of Earth's gravity. No human has ever experienced this. No one knows exactly what will happen, but we have clues. Bones may become lighter, frames may become taller, muscles may develop differently, cardiovascular systems may adapt to lower physical demands. The descendants of Martian settlers may eventually become physically different from Earth-born humans, not because they wanted to, not because evolution suddenly accelerated, but because biology always responds to its environment, slowly, patiently, relentlessly. And this raises an uncomfortable possibility. What if, after thousands of years, Earth and Mars are inhabited by people who can no longer comfortably live on each other's worlds? Imagine an adult born on Mars. They have spent their entire life under weak gravity. Their body has developed accordingly. Now imagine bringing them to Earth. Suddenly they weigh almost 3 times as much. Every movement becomes exhausting. Their heart must work harder. Their bones experience stress they were never designed to handle. Standing becomes tiring. Walking becomes painful. Running may become impossible. Earth itself could feel like a prison. Likewise, an Earth-born human visiting Mars might initially feel almost superhuman. They could jump higher, carry heavier loads, move more easily. But over time, their body would begin adapting as well, because the environment always wins. This is the first lesson of space. You do not conquer worlds. Worlds slowly reshape you. And Mars may only be the beginning, because the solar system is full of places that challenge our assumptions about what human civilization should look like. Take the asteroid belt. Most people imagine it as a crowded region where enormous rocks constantly collide. In reality, the asteroid belt is mostly empty. The distances between objects are enormous. But hidden inside this vast emptiness is something extraordinary. Resources. Almost unimaginable amounts of resources. Iron, nickel, water, carbon, platinum, rare metals. The building materials for entire civilizations. Everything needed to build habitats, fuel stations, spacecraft, factories, entire cities. And once humanity begins using these resources, something profound happens. For the first time in history, civilization is no longer dependent on planets. Think about that. For billions of years, life has been trapped on planetary surfaces. Every civilization in human history has depended entirely on one world. But asteroids offer another possibility: living in space itself. At first, this sounds absurd. How can empty space be more practical than planets? Because planets are difficult. Gravity is expensive. Launching materials from Earth requires enormous amounts of energy. Every kilogram costs money. Every rocket fights against gravity. In space, there is no deep gravity well. Resources can be moved far more easily. Habitats can be constructed exactly as needed. Gravity can be created artificially. Temperature can be controlled. Atmospheres can be designed. Entire environments can be customized. Ironically, the easiest place for human civilization to expand may not be on planets at all. It may be inside gigantic rotating habitats orbiting the sun. Imagine a cylinder dozens of kilometers long. Inside it are forests, lakes, cities, parks, artificial skies, homes, children going to school, people living completely normal lives. The habitat rotates slowly, creating artificial gravity. From inside, it feels almost identical to Earth. Except one thing. Outside your window is space. The stars never disappear. The sun never rises or sets naturally. Everything around you exists because engineers designed it to exist. Every breath, every tree, every drop of water. Your entire world is a machine. And this realization would fundamentally change human psychology. People born inside these habitats may grow up thinking very differently about nature. Because nature no longer surrounds them. Nature becomes something maintained, protected, managed. The forest exists because someone keeps it alive. The rivers exist because engineers designed them. The climate exists because machines regulate it. The distinction between civilization and environment begins disappearing. Humanity becomes its own ecosystem. And over thousands of years, millions of these habitats may spread throughout the solar system. Not one giant empire, not one enormous civilization, but millions of independent worlds, each with its own culture, its own traditions, its own values, its own understanding of what it means to be human. Because the solar system is much larger than our intuition allows. Even light needs hours to travel from the inner solar system to the outer planets. Messages arrive late. Conversations become impossible. Real-time communication disappears. If you live near Saturn, Earth is not a nearby place. It is another world, almost another era. By the time messages arrive, circumstances have already changed. Politics changes. Economies change. People die. Children are born. The shared present disappears. And when societies cannot share the same present, they begin to diverge. Slowly at first, then dramatically. A settlement near Jupiter may develop completely different laws from a settlement on Mars. People living inside asteroid habitats may have completely different ideas about ownership and government. Entire philosophies may emerge around resource management and survival. Religions may form around the fragility of life support systems. New traditions may develop around artificial gravity and rotating habitats. After enough time, the solar system would no longer feel like one civilization. It would feel like many civilizations sharing ancient ancestry. All descended from Earth, yet all increasingly different from one another. And perhaps the strangest change of all would be cultural memory, because memory decays. Even civilizations forget. Ancient languages disappear, empires vanish, entire peoples are remembered only through ruins. Now imagine 20,000 years. Could Earth remain culturally important for that long? Perhaps, but it may also become symbolic, the way modern humans think about ancient Mesopotamia, the place where everything began, important, historic, yet distant. The people of the future may study Earth the way we study ancient caves, not as home, but as origin. And that may be emotionally difficult for us to imagine, because we assume Earth is eternal. We assume future humans will feel about Earth the way we do. History suggests otherwise. Every generation redefines itself. Every civilization builds new identities. Space will simply accelerate this process. And then comes the biggest question of all. Will future humans even remain biologically human? Because over 20,000 years, technology itself becomes part of evolution. For almost all of history, evolution was slow, random, blind, but future civilizations may intentionally change themselves. Radiation-resistant genes, modified immune systems, enhanced bone growth, altered metabolisms, genetic adaptations for low gravity, traits optimized for life in specific environments. At first, these modifications may be medical necessities. Later, they may become normal, then expected. Eventually, people may be designed specifically for the environments they inhabit. Humans adapted for Mars. Humans adapted for orbital habitats. Humans adapted for outer system colonies. Not separate species, at least not initially, but no longer entirely identical either. And after 20,000 years, the definition of human may become far more flexible than it is today. Imagine standing on Mars 20,000 years from now. Above you is a sky that is no longer entirely red. Generations of engineering may have changed the atmosphere. Perhaps there are clouds. Perhaps patches of liquid water exist during the warmest seasons. Maybe there are small plants growing inside protected valleys. But Mars still isn't Earth. It never will be. Its gravity is still weaker. Its magnetic field is still gone. Its environment still demands constant maintenance. Every city remains an act of engineering. Every ecosystem remains an act of patience. Every generation understands a truth their ancestors on Earth never had to face. Survival is not automatic, it is manufactured. And that realization changes people. Imagine being born in a civilization where every child understands that one major system failure could kill thousands. Where oxygen is not taken for granted, where water is endlessly recycled, where waste is a resource, where every gram of material matters. People raised in such societies may think completely differently about abundance. Because on Earth, nature often hides consequences. In space, consequences are immediate. Waste too much water, you suffer. Ignore maintenance, you suffer. Allow infrastructure to fail, people die. Entire philosophies could emerge around this reality. The concept of responsibility itself may become sacred. Future societies may see carelessness as one of the worst possible crimes. Because in closed environments, individual actions affect everyone. On Earth, people can forget that they depend on systems. In space, nobody forgets. You hear the ventilation. You know where your water comes from. You understand how food is produced. You know what keeps you alive. Your civilization becomes visible. And perhaps this awareness makes future humans more cooperative. Or perhaps it creates entirely new conflicts. Because scarcity does strange things to intelligent species. Imagine millions of habitats scattered across the solar system. Some are rich, some are poor. Some control important resources. Some depend on trade. Some are politically stable. Some are not. Distance prevents central authority. No government can easily rule a civilization spread across billions of kilometers. By the time instructions arrive, conditions have already changed. This means future societies will be extraordinarily independent. Mars develops its own identity. The asteroid belt develops another. The moons of Jupiter become something entirely different. The settlements around Saturn become isolated worlds with their own customs and priorities. The solar system slowly transforms into a family of civilizations. Not enemies, not necessarily allies, simply different. And difference accumulates. History shows that isolated societies eventually diverge. Languages change, beliefs change, values change. Even concepts that seem universal today may disappear. Think about time. On Earth, time feels natural. 24-hour days, years based on Earth's orbit, months inspired by the moon. But what happens on other worlds? A day on Mars is slightly longer. A year is much longer. Some orbital habitats may create their own day-night cycles. Some colonies may operate continuously. Some people may live in places where natural sunlight never reaches them. Entire generations could grow up without ever seeing a sunrise. What happens to human psychology then? What happens to mythology? What happens to culture? Perhaps people create artificial seasons, perhaps festivals celebrate maintenance cycles. Perhaps entire religions emerge around light itself. A child born beneath the ice of Europa may consider the surface above to be a deadly wasteland. A child born on Titan may think darkness is normal. A person born inside an orbital habitat may consider planets strange and inefficient. The environments we inhabit shape our stories, and stories shape civilizations. Eventually, the solar system may contain thousands of different interpretations of what it means to be human. This cultural divergence would be extraordinary. But biological divergence may be even more profound. because 20,000 years is an enormous amount of evolutionary time. To put this into perspective, Jesus lived roughly 80 generations ago. Ancient Egypt existed roughly 200 generations ago. 20,000 years could represent almost 800 generations of human beings, 800 opportunities for adaptation, 800 opportunities for technological modification, 800 opportunities for change. Now imagine a community living permanently in low gravity. Generation after generation, their bodies slowly adjust. Their skeletons become lighter, their proportions shift, their cardiovascular systems adapt. Children born there no longer resemble their distant ancestors perfectly. Then imagine another population. People living in rotating habitats with Earth-like gravity. Their bodies remain much closer to ours. Then another population. Genetically modified individuals adapted to radiation. Then another. People whose lifespans have been dramatically extended. After enough time, humanity begins looking less like a species and more like a collection of related branches, all descended from one common origin, all recognizably connected, yet increasingly different. The idea of a single human experience begins disappearing because experience itself becomes dependent on environment. Imagine meeting someone from 20,000 years in the future. What would they think of us? Perhaps they would be shocked that we once lived entirely on one planet. Perhaps they would consider our political divisions absurd. Perhaps they would see us as brave, or primitive, or both. Perhaps they would look at our civilization the way we look at the people who painted on cave walls. The beginning of something much larger. Because from their perspective, we may represent humanity's childhood, and childhood eventually ends. This does not mean future humans become unrecognizable monsters. Popular science fiction often imagines dramatic transformations. The reality may be much more subtle. Different heights, different tolerances, different expectations, different ways of thinking, different relationships with nature, different relationships with risk, different ideas of home. These differences may seem small until they accumulate. And after thousands of years, accumulated differences become civilizations. They become identities. They become entirely new ways of existing. Then another possibility appears, a possibility perhaps more profound than any biological change. What if intelligence itself stops depending on biology? Because 20,000 years is enough time for technological progress that we can barely imagine. Consider our own history. 20,000 years ago, there were no cities. Today, we possess artificial intelligence, nuclear energy, global communication, genetic engineering, space telescopes. And all of this happened within an incredibly short period of time. Project that progress forward, not linearly, not exponentially, simply forward. The possibilities become difficult to comprehend. Artificial organs, synthetic bodies, brain-computer interfaces, digital memory, cognitive enhancement. Eventually, perhaps even the ability to preserve human consciousness in entirely new forms. No one knows whether true mind uploading is possible. No one knows whether consciousness can exist independently of biological brains. But future civilizations will almost certainly explore these questions. Because space rewards durability. Machines do not require oxygen. Machines do not suffer from low gravity. Machines can tolerate environments that biological humans cannot. The pressure to modify ourselves may become overwhelming. Imagine a civilization around Saturn. Sunlight is weak. Travel times are enormous. Resources are precious. Lifespans matter. Information matters. Efficiency matters. In such an environment, technological augmentation may become normal, then expected, then invisible. At what point does a heavily modified human stop being human? There may never be a clear answer. Perhaps humanity becomes a spectrum. Biological humans, genetically modified humans, synthetic humans, digital minds, entire populations existing in ways we cannot currently imagine, yet all descended from us. This possibility is both terrifying and beautiful, because it suggests that humanity's future is not one thing. It is many things, many paths, many experiments, many forms of intelligence exploring existence in different ways. And throughout all of this, Earth remains behind. A small blue world orbiting an ordinary star, the birthplace of everything. But even Earth is not eternal. The sun itself is changing, slowly, imperceptibly, yet continuously. Every billion years it becomes brighter, warmer, more energetic. One day Earth's oceans will disappear. One day complex life may become impossible. One day the inner solar system will change forever. 20,000 years is nowhere near that timescale. But future civilizations will understand something we often forget. Nothing lasts forever. Not planets, not stars, not civilizations. Permanence is an illusion. Everything changes, everything evolves, everything moves. Perhaps this is the greatest lesson space can teach us. Survival is not about finding a permanent home. There may be no permanent homes in the universe. Survival is about adaptation, flexibility, resilience, the ability to continue despite change. If humanity survives 20,000 years in space, our descendants may inhabit Mars, the asteroid belt, Europa, Titan, and places we have not yet imagined. They may build cities larger than nations, habitats containing millions of people, civilizations spread across billions of kilometers. But the most extraordinary thing about them may not be where they live. It may be who they have become. Because after 20,000 years, humanity may no longer be one civilization. It may no longer be one culture. It may no longer even be one form of life. Instead, it may become something entirely new. A family of worlds. A family of intelligences. A family of descendants carrying the memory of one small blue planet. And somewhere in that unimaginable future, perhaps a child born beneath another sky will look upward and ask the same question humans have always asked. Who are we? Where did we come from? And what are we becoming? For almost all of human history, survival meant staying together. Our ancestors survived because they formed tribes, then villages, then cities, then nations. The larger our civilizations became, the safer we felt. But space changes that logic completely, because in the solar system, concentration becomes a weakness. Imagine that all of humanity still lives on Earth 20,000 years from now. One asteroid impact, one engineered pandemic, one runaway artificial intelligence, one supervolcanic eruption, one ecological collapse. And the story could end, not necessarily overnight, but permanently. Space changes this equation. If millions of people live on Mars, another million in orbital habitats, others around Jupiter and Saturn, and countless communities scattered throughout the asteroid belt, extinction becomes much harder. A disaster that destroys one world may never reach another. An impact on Earth would not affect Europa. A political collapse on Mars would not automatically spread to Titan. Distance becomes protection. For the first time in history, humanity could become resilient on a planetary scale. But resilience has a strange consequence. People no longer need each other in the same way. The survival of the species becomes decentralized. Humanity stops being one basket carrying all of its eggs. Instead, it becomes millions of baskets spread across the darkness. This sounds comforting, yet it creates a disturbing possibility. What if some branches of humanity stop caring about the others? Imagine a settlement around Saturn. The people there have never visited Earth. Their grandparents never visited Earth. Their great-grandparents never visited Earth. The communication delay with the inner solar system is measured in hours. Travel takes years. Most news arrives long after events have already happened. To these people, Earth may feel less real than ancient Rome feels to us. Yes, it exists. Yes, it is historically important. But emotionally, it is distant, abstract, almost fictional. Now imagine that Earth faces a crisis. Would a civilization around Saturn feel the same urgency that we would? Maybe, maybe not. Because empathy often depends on proximity, and the solar system is unimaginably large. This may become one of the greatest challenges humanity ever faces. Not technology, not resources, not physics, identity. How do you maintain a shared identity across billions of kilometers and thousands of years? How do you convince people living around another planet that they belong to the same civilization as people they have never met? History suggests this becomes increasingly difficult. Empires collapse because communication fails. Cultures drift apart. Values diverge. People stop seeing themselves as part of the same story. Now, multiply those forces by interplanetary distances. Humanity may slowly fragment into entirely new civilizations. Not through war, not through rebellion, but through time. Because distance is frozen time. Every message you receive from another world describes the past. The farther away a civilization becomes, the less you share the same present. And eventually, you stop sharing the same future. The people of Mars may pursue goals that seem irrational to Earth. The people of Europa may develop priorities nobody else understands. The asteroid belt may create economic systems that would appear bizarre to planetary societies. Different environments create different needs. Different needs create different values. Different values create different civilizations. This fragmentation may become so profound that the phrase human civilization no longer makes sense. Instead, there may be human civilizations. Plural, thousands of them. Some democratic, some authoritarian, some highly technological, some intentionally simple, some entirely biological, some heavily modified, some perhaps no longer biological at all, and every one of them will believe that their way of life makes sense. Because environments shape minds. A person born in an underground Martian city may develop a completely different relationship with risk than someone born on Earth. Imagine growing up knowing that a breach in the habitat wall could kill everyone around you, that every system matters, that every resource is precious. You might become extraordinarily cautious, or extraordinarily cooperative, or both. Now imagine someone born in a gigantic orbital habitat, containing millions of people and nearly unlimited energy from the sun. Their civilization may value experimentation, creativity, expansion, risk-taking. Entire philosophies may emerge from the environments people inhabit. Even morality itself could evolve. Concepts we consider obvious may become controversial. Property, privacy, individualism, community, freedom, responsibility. All of these ideas depend heavily on circumstance. A settlement where every liter of water matters may think very differently about ownership than a settlement with abundant resources. A community isolated beneath the ice of Europa may place extraordinary value on social harmony. An asteroid habitat dependent on constant maintenance may see technical competence as a moral virtue. Over 20,000 years, these differences accumulate, then deepen, then harden into identity, and identity changes history. Imagine a child born 10,000 years from now. Their ancestors have lived in space for hundreds of generations. Earth exists in museums and educational simulations. People still learn about it. They still know it is their ancestral world. But emotionally, it is no longer home. Then one day this child visits Earth. What would they feel? Wonder, disappointment, alienation. Imagine seeing oceans for the first time. Real clouds, natural rain. Birds flying through an open sky. Gravity pressing against your body. The smell of forests. The sound of wind moving through trees. Experiences that we consider ordinary may feel almost supernatural. Earth itself may become one of the most extraordinary places in the solar system, not because it is technologically advanced, but because it is natural, because nowhere else is quite like it. Future humans may visit Earth the way we visit historical monuments, not as residents, as pilgrims, as tourists, as descendants returning to the place where their story began. And perhaps they will realize something profound. Every civilization in the solar system, every habitat, every moon settlement, every orbital city, every modified human, every artificial intelligence, every future culture exists because a single species once evolved on one fragile planet. A planet that, by cosmic standards, is almost impossibly fortunate. The right atmosphere, the right gravity, the right chemistry, the right temperature, the right star, everything aligned. And from that small beginning came a civilization capable of imagining worlds beyond its own. Perhaps this is the real significance of space colonization. Not expansion, not conquest, continuity. Because intelligence is rare, maybe unimaginably rare. The universe is nearly 14 billion years old. The Milky Way contains hundreds of billions of stars. Yet as far as we know, only one world has produced a species capable of wondering about its own future. Us. This may change. Perhaps the universe is full of civilizations, or perhaps it is almost empty. We simply do not know. But we do know this. If intelligence is rare, then its survival matters. The extinction of humanity would not merely be the extinction of one species. It could be the loss of one of the universe's few opportunities to know itself. That sounds poetic, but it may also be scientifically true. Because every telescope we build, every equation we solve, every question we ask, is the universe becoming aware of its own existence. And 20,000 years from now, our descendants may continue that process. Perhaps they will build observatories around distant worlds. Perhaps they will explore the outer reaches of the solar system. Perhaps they will discover life elsewhere. Perhaps they will become the first civilization to leave its home star entirely. Or perhaps they will simply survive. And survival alone would already be extraordinary, because the greatest enemy of civilization may not be war, or disease, or even physics. It may be time. Time erodes everything. Languages disappear, buildings collapse, memories fade, knowledge is forgotten, civilizations die. 20,000 years is enough time for countless rises and falls. Countless golden ages, countless disasters, countless rebirths. The future will not be a straight line. It never has been. Humanity's journey through space will likely be messy, complicated, sometimes tragic, sometimes beautiful. Some colonies may fail. Entire cultures may vanish. Technologies may be lost. Histories may be forgotten. But as long as some branch of humanity survives somewhere among the stars, the story continues. And perhaps that is enough, because permanence was never the goal. Nothing in the universe is permanent. Stars die, galaxies collide, even black holes eventually evaporate. The universe itself changes. Everything changes. The question is whether intelligence can change with it. Whether a species evolved to survive short winters and local dangers, can learn to think in epochs, can learn patience, can learn resilience, can learn to build civilizations that endure longer than memory itself. 20,000 years is not eternity. On cosmic timescales, it is barely a moment, yet it may be enough time to answer one of the greatest questions ever asked. Can humanity become something larger than a planetary civilization? Can intelligence survive long enough to matter? And if it can, what will humanity look like after 20,000 years in space? Perhaps taller, perhaps genetically modified, perhaps partially synthetic, perhaps spread across countless worlds, perhaps divided into thousands of cultures, perhaps transformed in ways we cannot imagine. But maybe one thing will remain unchanged: curiosity. Because 20,000 years ago, our ancestors sat beside fires and looked at the stars. Today, we do the same. And 20,000 years from now, somewhere beneath another sky, another descendant of humanity may still look upward and ask, what lies beyond? What else is out there, and what comes next? But there is another possibility, a possibility so strange that it barely feels real. What if, after 20,000 years, humanity no longer lives primarily on planets at all? Because planets are expensive. They are difficult. Gravity traps resources. Atmospheres must be maintained. Distances are enormous. And despite all of their beauty, planets impose limitations. Space itself does not. Imagine the solar system 20,000 years from now. You would not necessarily see gigantic cities covering Mars. You might not see entire planets transformed into Earth-like worlds. Instead, you may see something far quieter. Millions of habitats, millions of artificial worlds, each one containing a few thousand people, or perhaps a few million, scattered across the darkness. From a distance, the solar system could appear almost empty. No galactic empires, no planet-sized megastructures, no impossible engineering projects visible from light years away. Just countless small lights moving silently around the sun. This may actually be the most stable form of civilization, because redundancy beats grandeur. A civilization concentrated on one world is fragile. A civilization distributed across millions of habitats is resilient. No single failure ends the story. No single disaster destroys everything. Some habitats fail, others survive. Some civilizations disappear, others continue. Humanity becomes like a forest. Individual trees die, the forest remains. This is perhaps the deepest reason for colonizing space. Not expansion, not greed, not conquest, insurance. The universe is dangerous. Asteroids exist. Supernovae exist. Gamma-ray bursts exist. Pandemics exist. Artificial intelligence risks exist. Civilizational collapse exists. The question is not whether dangers exist. The question is whether intelligence can become distributed enough to survive them. For almost 4 billion years, life on Earth had no backup. One world, one biosphere, one opportunity. Humanity may become the first species capable of changing that, the first species capable of spreading itself across multiple worlds. And if we succeed, extinction itself changes. Today, we imagine extinction as a single event, a catastrophe, an ending. But for a civilization spread throughout the solar system, extinction becomes a process, a long thinning. Some branches disappear, others remain. Some cultures die, others adapt. Some habitats fail, others rebuild. Humanity no longer rises and falls together. It survives unevenly, messily, imperfectly, but it survives. This may fundamentally change how future humans think about death. Think about it. We evolved in small tribes. The loss of our community often meant the end of everything. Future humans may grow up in civilizations where continuity matters more than permanence, where systems fail and are rebuilt, where habitats come and go, where entire cultures emerge and disappear over millennia, where change is normal. Perhaps future humans become psychologically comfortable with impermanence. Perhaps they understand something we struggle to accept: that survival does not require things to remain the same. It only requires continuity. The river remains a river even though its water constantly changes. Perhaps civilization is similar. Perhaps humanity can remain humanity even if everything about it changes. Its biology, its culture, its appearance, its worlds, its technologies, its languages. Because identity is strange. You are not physically made from the same atoms you had years ago. Your cells constantly replace themselves. Your thoughts change. Your memories change. Yet you still consider yourself the same person. Perhaps civilizations work the same way. Perhaps species work the same way. Perhaps humanity can survive enormous transformation while remaining fundamentally continuous. But there is a limit to this idea. At some point, change becomes difficult to define. Imagine meeting a descendant from 20,000 years in the future. Their body is adapted to low gravity. Their lifespan is several centuries. Their immune system has been genetically modified. Their memory is partially augmented by technology. Their society exists inside a rotating habitat orbiting Saturn. Their language is descended from ours but sounds completely different. Their culture has no concept of nations, no concept of natural weather, no concept of countries, no concept of living exclusively on one world. Would you consider them human? Probably, but now, imagine someone else. An intelligence descended from humanity, existing entirely inside artificial environments, perhaps digital, perhaps synthetic, perhaps able to copy memories, perhaps able to exist without biological bodies. Would they still be human? The answer becomes much less clear, and maybe there is no correct answer, because humanity has never been a static thing. We constantly redefine ourselves. Agriculture changed us. Cities changed us. Writing changed us. Industrialization changed us. Computers changed us. The internet changed us. Artificial intelligence will change us. Space may change us more than anything before it. The human story has always been one of adaptation. 20,000 years in space simply extends that process. But there is something beautiful hidden inside this uncertainty. No matter how strange our descendants become, they will still be connected to us. Every future civilization, every Martian city, every habitat drifting through the asteroid belt, every child born around Saturn, every modified human, every synthetic intelligence descended from our species. All of them will exist because people living in the 21st century made a decision. The decision to continue, to explore, to survive, to leave Earth, to become something more than a single planet civilization. And perhaps our descendants will remember that. Perhaps not as detailed history, not as names and dates, but as mythology. Imagine children 20,000 years from now learning about Earth, learning that every human civilization once existed on one small world, learning that oceans covered most of its surface, learning that billions of people lived beneath a blue sky, learning that their ancestors looked at the stars and wondered if they would ever reach them. To those children, we may feel impossible, the same way ancient humans feel impossible to us, yet we are connected. Every person who has ever lived belongs to the same unbroken chain. 20,000 years ago, someone looked up at the night sky. Tonight, we do the same. 20,000 years from now, someone else may do it again. Different world, different body, different civilization, different definition of humanity, but the same curiosity, the same questions, the same need to understand existence. Perhaps that is the real constant of human history. Not our biology, not our cultures, not our technology. Curiosity, the desire to know, the desire to go farther, the refusal to remain inside boundaries. Maybe that is what survives 20,000 years in space. Not a specific civilization, not a specific appearance, not even a specific form of life, but a pattern, a way of thinking, a flame carried from one generation to the next. A small species that once evolved on an ordinary planet around an ordinary star, and eventually learned to spread its questions across the solar system. 20,000 years is not enough time to become eternal. The sun will still shine, the galaxies will still drift, the universe will remain unimaginably large. But 20,000 years may be enough to decide something extraordinary. Whether intelligence can survive long enough to outgrow its birthplace. Whether a civilization can learn to think in millennia instead of elections. Whether descendants can remain connected despite distance and change. Whether curiosity itself can become resilient. And if humanity succeeds, the solar system will not remember us as conquerors. It will remember us as the generation that took the first steps. The generation that accepted uncertainty. The generation that looked into a hostile universe and decided that survival was worth the risk. Because one day, somewhere far beyond Earth, a child may stand beneath another sky and ask a simple question. Where did we come from? And the answer will begin with a small blue planet, and a civilization that refused to believe its story should end there. And then there is a question almost nobody asks. What happens psychologically to a civilization that no longer has a horizon? On Earth, our minds evolved in open landscapes. For hundreds of thousands of years, humans could walk for days. They could climb mountains, watch sunsets, follow rivers, see storms approaching from the distance. The world felt enormous. Even today, despite cities and technology, most people still experience nature in some form. A blue sky, clouds, wind, rain, birds, the changing seasons. These things are so ordinary that we rarely think about them, but they have shaped human psychology for millennia. Now imagine spending your entire life inside a rotating habitat. You know every corridor, every room, every park, every artificial lake. The horizon is not infinite, it is engineered. The sky is not natural, it is projected. The seasons are programmed. Even the weather may be optional. What does that do to the human mind? Nobody knows, because we have never lived that way. Perhaps future humans become more comfortable with artificial environments than natural ones. Perhaps they feel anxiety when standing beneath an open sky. Perhaps they prefer controlled ecosystems, predictability, stability. The idea of wilderness itself may become strange. After all, wilderness is dangerous. On Earth, we romanticize nature because our civilization protects us from most of its dangers. Future space civilizations may see things differently. They may see unmanaged environments as chaotic and irresponsible. A forest fire, a hurricane, an earthquake. To them, these may appear not beautiful, but absurd. Why tolerate such risks when environments can be engineered? The descendants of humanity may eventually consider natural worlds primitive, not because they hate nature, but because they are accustomed to control. This is difficult to imagine because we are creatures of Earth. We instinctively trust natural environments. Future humans may instinctively trust machines. Imagine a child born inside an orbital habitat. Since birth, life support systems have never failed. Artificial gravity has always existed. Recycling systems have always functioned. For them, civilization itself becomes nature. Machines become part of reality in the same way rivers and mountains are part of reality for us. The distinction disappears. This may fundamentally alter philosophy. Think about our relationship with death. Throughout history, human beings accepted mortality because nature appeared unavoidable. Storms happened, disease happened, famine happened. Death felt like a force beyond our control. But in highly engineered societies, causes of death increasingly become technical problems, systems failures, design flaws, medical limitations. The idea that everything can potentially be fixed may slowly change how future humans think. Imagine civilizations where lifespans routinely exceed 200 years, perhaps even longer. People would think differently. Relationships would be different. Politics would be different. Education would be different. The concept of generations would change completely. Today, most societies are shaped by rapid generational turnover. People are born, they age, they die. Knowledge is lost and rediscovered. Now imagine individuals living for centuries. A person born on Mars may personally remember events that we would consider ancient history. Entire political systems may evolve differently when decision-makers remain alive for hundreds of years. Patience itself may become a cultural trait. Projects lasting decades may feel short-term. Projects lasting centuries may become reasonable. Terraforming efforts, megastructures, long-duration scientific experiments. Future civilizations may think on timescales we struggle to comprehend. Because perhaps the greatest limitation of humanity today is not intelligence, it is lifespan. We think in decades because we live in decades. Space may eventually force us to think in centuries. And once civilizations begin thinking in centuries, their priorities may change completely. Imagine planning a city that will not be completed for 400 years. Imagine planting forests that your descendants' will enjoy. Imagine engineering habitats expected to survive for 10,000 years. Our relationship with time would fundamentally change. This may be one of the most important transformations of all, because space itself operates on deep time. Planets form over millions of years, stars evolve over billions, galaxies change over unimaginable periods. Human civilization often feels rushed because our lives are short. Future civilizations may become more patient, more deliberate, more resilient. Perhaps the true challenge of space is not engineering, it is learning patience. Because nothing in the solar system happens quickly. Terraforming takes millennia. Cultural development takes centuries. Interplanetary societies require generations to mature. The people who begin these projects will rarely see their completion. This demands something unusual: trust in the future. The belief that unknown descendants matter. The belief that people who do not yet exist deserve opportunities. This way of thinking is surprisingly difficult. Humans evolved to solve immediate problems. Food, shelter, danger. Our instincts are short-term. Yet every major civilization depends on long-term thinking. Roads, libraries, universities, scientific institutions. Space may demand even greater patience. Because building a civilization among the stars is not a project, it is an inheritance. One generation begins, another continues, another improves, another repairs, another expands. For 20,000 years, hundreds upon hundreds of generations, the civilization that eventually emerges may be unrecognizable, yet every generation contributes. Every person becomes a temporary caretaker of something much larger than themselves. This idea may become sacred. Because once humanity spreads through the solar system, nobody can build civilization alone. No single lifetime is long enough. No single world is sufficient. Everything becomes collaborative, intergenerational, continuous. Perhaps future societies develop entirely new philosophies around stewardship, around maintaining systems for people they will never meet. Because every habitat depends on previous generations. Every city depends on inherited knowledge. Every civilization depends on continuity, and continuity itself is fragile. Knowledge can disappear. Archives can be lost. Wars can happen. Technologies can be forgotten. History shows this repeatedly. Entire civilizations have vanished. Languages have disappeared. Engineering techniques have been lost. The future is not guaranteed. A civilization spread across the solar system may still experience dark ages. Colonies may fail. Trade networks may collapse. Entire populations may become isolated. Imagine an orbital habitat losing contact with the rest of humanity for centuries. The descendants living there would slowly develop their own culture, their own myths, their own interpretation of history. Perhaps they would barely remember Earth. Perhaps they would create legends about their origins. Perhaps they would believe they had always existed among the stars. 20,000 years allows for extraordinary possibilities. Not only progress, but forgetting. Because forgetting is one of the most powerful forces in history. Entire peoples have forgotten where they came from. Entire nations have reinvented their identities. Future civilizations may do the same. The story of Earth itself may become fragmented. Different worlds may remember different versions of history. Some may preserve archives. Others may lose them. Some may romanticize Earth. Others may reject it. The solar system may contain thousands of competing narratives about humanity's origins. And maybe that is unavoidable. Because memory changes, stories evolve, identity adapts. Perhaps what matters is not preserving every detail. Perhaps what matters is preserving one simple truth: that humanity came from somewhere, that intelligence has a history, that civilization is an inheritance, and that every generation is responsible for carrying it forward. Because 20,000 years from now, the people living among the stars may no longer look like us. They may no longer think like us. They may no longer share our values, our languages, or even our biology. But they will still be part of the same story. A story that began when a curious species first looked up at the night sky and wondered whether those distant lights could ever become home. And perhaps the strangest consequence of 20,000 years in space is this: humanity may eventually stop thinking of itself as a species that lives somewhere. Instead, it may begin thinking of itself as a process. Today, every civilization in history has been tied to geography. Ancient Egypt depended on the Nile. Rome depended on the Mediterranean. Modern civilization depends on Earth itself. Location defines identity. But what happens when your civilization exists in millions of moving habitats? When cities orbit planets? When entire populations migrate through space? When habitats can be dismantled, rebuilt, and relocated, the meaning of place begins to change. Home is no longer a piece of land. Home becomes relationships, systems, memories, communities. A habitat may move millions of kilometers during your lifetime, yet it remains home because the people remain. This would be one of the greatest psychological transformations in human history. For the first time, civilization becomes fundamentally mobile. Imagine asking someone 20,000 years in the future where they are from. The answer may not be a planet. It may be a habitat, a fleet, an orbital community, a cultural network. Identity may become detached from geography entirely, because geography itself becomes optional. This is something Earth has never experienced. Every nation has borders because land has borders. Space does not. The solar system is mostly empty. Civilizations can move, expand, contract, split, merge. The political structures we consider normal today may eventually appear ancient. Perhaps future humans organize themselves around shared values instead of territory, around scientific goals, religious beliefs, economic systems, or simply common history. Entire civilizations may exist across thousands of habitats spread throughout the solar system. Distance matters less when communication technologies improve. And yet, distance never disappears completely. Physics remains. The speed of light remains. Travel times remain. The solar system always stays enormous. This means future humanity may experience something completely new. Unity without proximity. Belonging without geography. Civilization without nations. At least for some communities. Others may remain strongly regional. Mars may develop its own identity. Europa its own, Titan its own. The asteroid belt may contain hundreds of unique cultures. The future will likely be messy, complicated, contradictory, just like history has always been. But there is another possibility that feels almost inevitable. Some people may simply choose to leave, not leave Earth. Leave civilization itself. Because whenever humanity expands into new frontiers, some individuals seek independence. Explorers, nomads, pioneers, outcasts. The solar system provides almost unlimited opportunities for this. Imagine a family living inside a tiny habitat orbiting far beyond Neptune. They rarely communicate with anyone. They grow their own food, maintain their own systems, educate their own children. To them, distance is freedom. They have no interest in politics on Earth or Mars. No desire to participate in massive civilizations. They simply exist quietly among the stars. 20,000 years from now, there may be countless communities like this. Small worlds drifting through darkness. Independent societies invisible to everyone else. The solar system may become far more diverse than we can currently imagine, because environments create possibilities, and possibilities create lifestyles. Perhaps entire philosophies emerge around solitude, others around collective living. Some cultures may prioritize technological progress, others may intentionally reject advanced technology. Some may become deeply spiritual, others radically scientific. The future is not one path. It is countless experiments occurring simultaneously. And perhaps that is humanity's greatest strength. Diversity. Not just biological diversity, not just cultural diversity, civilizational diversity. Different ways of solving problems, different ways of understanding reality, different responses to the challenges of existence. A species spread across the solar system gains resilience because not everyone thinks the same way. Some civilizations fail, others succeed. Some make mistakes, others learn from them. Some disappear, others inherit their knowledge. Humanity becomes an ecosystem of ideas, a constantly evolving network of experiments. And this may ultimately be what allows intelligence to survive. Because no single solution is perfect. No civilization remains correct forever. Conditions change, environments change, threats change. The ability to adapt may matter more than the ability to dominate. Nature teaches this lesson repeatedly. The most successful organisms are rarely the strongest. They are the most adaptable. Perhaps civilizations obey the same rule. 20,000 years is enough time for extraordinary change, enough time for countless failures, enough time for astonishing successes, enough time for entirely new branches of humanity to emerge, but maybe not enough time to answer every question, because even after 20,000 years, the universe will remain mostly unknown. the nearest stars will still be unimaginably distant. Most of our galaxy will remain unexplored. The great mysteries of existence may still persist. What is consciousness? Are we alone? Why does the universe exist at all? What lies beyond our cosmic horizon? Future humans may possess technologies we cannot imagine, yet they will probably still ask questions, because every answer creates new mysteries. Knowledge expands the boundaries of ignorance. The more we understand, the more we realize how much remains unknown. Perhaps curiosity itself is endless. And if that is true, then 20,000 years in space may only be the beginning. Not the conclusion of the human story, not its final form, not its ultimate destination, only another chapter. Because the universe is old beyond comprehension. Stars existed for billions of years before Earth formed. They will continue existing for billions more. 20,000 years is almost nothing. A blink, a single heartbeat in cosmic history. Yet within that brief moment, humanity could transform from a species confined to one planet into a civilization spread across an entire solar system. That alone would be one of the most extraordinary transitions in the history of life. A species that once feared the darkness between trees may eventually inhabit the darkness between worlds. A species that once painted animals on cave walls may build cities around distant planets. A species that once believed the stars were unreachable lights may raise children beneath entirely different skies. And perhaps those future children will sometimes look back toward the inner solar system, back toward a small blue planet orbiting an ordinary star, back toward a world they may never visit, a world they know only from stories. And perhaps they will feel something we still feel today when looking at ancient ruins. A strange sense of connection. A sense that despite all differences, despite all distance and time, something of themselves began there. Because every civilization needs an origin story. Every person asks where they came from. Every culture seeks roots. For 20,000 years, humanity may change almost beyond recognition, but one fact will remain. Every future human, every future civilization, every future intelligence descended from us will trace its ancestry to one tiny world suspended in darkness. A world with oceans, clouds, forests, and blue skies. A world where an intelligent species first learned to ask impossible questions. And maybe that is what humanity ultimately becomes after 20,000 years in space. Not conquerors, not masters of the universe, but carriers of questions. A civilization that learned to move from world to world while preserving its curiosity. A species that discovered survival is not about remaining unchanged. It is about continuing the search for meaning. Because somewhere 20,000 years from now, beneath another sky and around another world, someone will still look upward and wonder, what lies beyond? And that simple question may be the most human thing of all. But eventually, after 20,000 years, humanity may face a problem that no civilization in history has ever experienced: success. Because survival changes incentives. Imagine that humanity has done everything right. Mars is inhabited. Millions of orbital habitats exist throughout the solar system. The asteroid belt has become an industrial network stretching across millions of kilometers. Outposts survive around Jupiter and Saturn. Knowledge has been preserved. Civilizations have endured. Humanity is no longer at risk of a single planetary extinction. Now what? For the first time in history, our species may no longer have an obvious frontier. This sounds impossible because we live during an age of exploration. There are still oceans to study. The deep earth remains mysterious. The solar system is almost entirely unexplored, but 20,000 years is a long time. Enough time to map every major asteroid, enough time to build settlements around countless worlds, enough time to know our solar system intimately. And when a species runs out of nearby frontiers, something interesting happens. It turns inward. Imagine civilizations that have existed for thousands of years. Their citizens live for centuries. Material needs are largely solved. Automation performs most dangerous labor. Energy is abundant. Information is everywhere. What motivates such societies? Perhaps art becomes more important than economics. Perhaps philosophy becomes a major occupation. Perhaps entire civilizations dedicate themselves to understanding consciousness. Perhaps others become obsessed with history, others with mathematics, others with engineering. The future may contain cultures that seem incomprehensible to us because survival no longer dominates every decision. Human beings today spend enormous energy solving immediate problems: food, housing, security, money. Future societies may devote far more attention to questions that seem luxurious to us. What is beauty? What creates meaning? What experiences are worth having? What responsibilities do intelligent beings have? How should consciousness be preserved? What forms of life deserve moral consideration? These questions may become central, because the more successful a civilization becomes, the more psychological questions begin to matter. A species can survive physically while struggling emotionally. This may become one of the greatest challenges of long-term space civilization. Purpose. Imagine being born into a civilization that has existed for 10,000 years. The great engineering projects are complete. The habitats function perfectly. There are libraries older than entire nations from our time. You can travel between worlds. Your lifespan is long. Your society is stable. What do you strive for? History suggests that meaning cannot simply be provided. People need challenges, goals, mysteries, a sense that the future matters. Perhaps this is why exploration never truly ends, because the universe is effectively infinite from a human perspective. Even if the solar system becomes home, the stars remain. Proxima Centauri lies more than 4 light-years away. Thousands of other stars surround us. The Milky Way contains hundreds of billions. The frontier simply moves farther away. And perhaps that is enough. Perhaps humanity never reaches a final destination because no such destination exists. Every answer creates another question. Every world reveals another horizon. Every achievement exposes another challenge. 20,000 years in space may teach humanity a profound lesson. The purpose of civilization is not arrival. It is continuation. Think about our ancestors, the people who first crossed mountains, the people who sailed across oceans, the people who built observatories and universities. None of them knew where the story would lead. Most never saw the results of their efforts, yet they continued, because progress is often an act of faith. Faith that unknown descendants matter. Faith that the future exists. Faith that curiosity deserves to survive. The first Martian settlers will likely never see a fully developed Martian civilization. The people who begin building orbital habitats may never witness millions of habitats scattered throughout the solar system. The scientists creating early technologies may never know what they eventually become. Yet their efforts matter, because civilization is cumulative. Every generation inherits and contributes. This chain may become humanity's greatest achievement. Not a machine, not a city, not a planet. Continuity itself. The ability to preserve knowledge and purpose across 20,000 years. Because 20,000 years is longer than every empire. longer than every religion in its current form, longer than nearly every language that exists today. Maintaining continuity for such a duration may be harder than any engineering challenge. It requires education, archives, shared stories, cultural memory, institutions capable of surviving unimaginable change. And perhaps this is where humanity's future will ultimately be decided. Not on Mars, not in the asteroid belt, not on Europa, but in our ability to remember why we left Earth in the first place. Because civilizations can forget. History proves this repeatedly. Knowledge disappears, lessons are lost, mistakes are repeated. The future may experience its own dark ages, its own collapses, its own renaissances. 20,000 years will almost certainly include periods of decline. No civilization remains permanently stable. Some habitats may fail. Entire cultures may vanish. Technologies may be rediscovered multiple times. The human story may become cyclical. Periods of expansion followed by contraction. Periods of unity followed by fragmentation. Periods of optimism followed by crisis. And yet, as long as some branch survives, the story continues. This is perhaps the most extraordinary consequence of becoming a multi-world species. Failure itself changes meaning. A civilization can collapse without ending the species. A world can die without ending the story. Extinction becomes harder. Recovery becomes possible. History gains redundancy, and redundancy creates resilience. Nature discovered this long ago. Life survived multiple mass extinctions because it diversified. Some branches disappeared, others endured. Perhaps intelligent life must learn the same lesson. Not to avoid all failures, but to avoid single points of failure. Because no system is perfect, no world is eternal, no civilization is guaranteed. Only adaptation offers long-term survival, and adaptation requires change. This may be difficult for us to accept because we often imagine the future as an improved version of the present. It almost certainly will not be. Future humanity may be stranger than we are comfortable imagining. Different bodies, different cultures, different moral systems, different relationships with technology, different definitions of family, community, and identity. Some future humans may feel more connected to artificial intelligences than to Earth-born people. Others may dedicate themselves to preserving ancient traditions. Others may reject technological modification entirely. The solar system may contain every possible version of humanity. And perhaps that diversity is not a weakness. Perhaps it is exactly what survival requires, because the universe is unpredictable. Different environments reward different solutions. Different dangers require different responses. A civilization with only one way of thinking may become fragile. A civilization containing countless experiments becomes resilient. 20,000 years in space may therefore produce something remarkable. Not one humanity, but many humanities. Many interpretations of what it means to be intelligent. Many ways of experiencing existence. Many descendants carrying different pieces of a shared origin, yet all connected by one simple fact. Every one of them came from Earth. Every one of them descends from people who once looked at the stars and wondered whether they could ever become home. And perhaps 20,000 years from now, after all the changes, after all the transformations, after all the new worlds and civilizations, one thing will remain surprisingly familiar. A child somewhere in the solar system will step outside their habitat. They will look upward. They will see distant lights scattered across darkness. And they will feel exactly what our ancestors felt 20,000 years ago. Curiosity, wonder, a sense that something lies beyond the horizon. because perhaps that feeling is older than civilization itself, older than agriculture, older than writing, older than cities. The desire to know what lies beyond may be the most ancient and most enduring part of being human. And if that survives, then maybe no matter how much we change, no matter how many worlds we inhabit, no matter how strange our descendants become, we will still recognize ourselves. And maybe the most important question is not what humanity will look like after 20,000 years in space. Maybe the real question is whether we will still understand why we went there. Because every civilization eventually forgets something. Ancient people built monuments whose original meanings were lost. Languages disappeared. Entire religions vanished. Cities were buried beneath sand and forests. History is not a perfect record. It is a survivor. And over 20,000 years, even the greatest achievements may become myths. Imagine a child living in an orbital habitat around Jupiter. Their world is ancient. Its oldest sections were built thousands of years ago. Generations have lived and died there. The habitat has been expanded countless times. The original builders are long forgotten. The names of its first engineers survive only in archives that almost nobody reads. The child learns in school that their ancestors came from a place called Earth. They see pictures of blue oceans and green forests. They know humans once lived entirely on a single planet. But emotionally, none of this feels real. Because history eventually becomes abstract. Think about ancient Mesopotamia. You know it existed. You know civilization emerged there. But you do not emotionally feel connected to it. Future humans may feel the same way about us. To them, the 21st century may seem impossibly distant, a primitive era, an age before interplanetary civilization, an age before artificial habitats became ordinary, an age before humanity learned to survive beyond Earth. And perhaps they will misunderstand us. Perhaps they will think we were more unified than we really were. Perhaps they will imagine we understood our future. Perhaps they will romanticize us. Every civilization romanticizes its origins. The Romans romanticized ancient heroes. Modern societies romanticize explorers and inventors. Future humans may do the same. They may tell stories about the first astronauts, about the first Martian settlers, about the first children born beyond Earth. These people may become legends, not because they were perfect, but because beginnings matter. Every civilization seeks an origin story, and our era may eventually become one, the age when humanity took its first uncertain steps into the darkness, the age when we were still confined to one planet, the age when nobody knew whether becoming a multi-world civilization was even possible, and perhaps future humans will envy us. That may sound strange. Why would advanced civilizations envy us? Because we live at the beginning. We live during one of the most extraordinary moments in history. The transition, the first chapter, the moment when space is still mysterious, the moment when the future remains unwritten. Future civilizations may inherit worlds, habitats, and technologies that already exist. But we experience something they never can. The first time, the first images, the first landings, the first questions, the first attempts. There is something irreplaceable about beginnings, and perhaps our descendants will understand that. Perhaps they will look back at this era with fascination, because every civilization eventually becomes curious about itself. Where did we come from? Why did our ancestors make the choices they made? Why did they risk everything to leave Earth? The answers may surprise them, because the truth is, we are not driven only by necessity. Human beings are explorers. For most of our history, we walked into places that terrified us, across deserts, across oceans, across frozen landscapes, not because it was easy, not because success was guaranteed, but because curiosity is one of our deepest instincts. There is something inside us that resists boundaries, a refusal to accept that the horizon is final. Perhaps this instinct evolved because exploration increased survival. Or perhaps it is simply a byproduct of intelligence itself. An intelligent species naturally asks questions, naturally seeks novelty, naturally wants to know what lies beyond, and eventually, curiosity becomes destiny. Because every frontier that humans have encountered has eventually been crossed. Every ocean, every mountain range, every continent. The stars may simply be the next horizon. 20,000 years from now, our descendants may no longer see the solar system as a frontier. To them, it may feel ordinary, familiar, home. And perhaps they will look toward the stars the same way we look toward Mars today. Not as impossible destinations, but as difficult destinations. Engineering challenges, long-term projects, questions waiting to be answered. Because frontiers never disappear. They simply move farther away. This may be the deepest lesson of human history. There is no final destination, no ultimate point of arrival. Civilization is movement, change, adaptation. Questions leading to more questions. 20,000 years in space will not complete humanity's story. It may only prepare us for another beginning. Perhaps by then, the first interstellar missions are leaving the solar system. Perhaps enormous generation ships are crossing the darkness between stars. Perhaps artificial intelligences are exploring regions where biological humans cannot survive. Perhaps entirely new forms of civilization are emerging. The future may remain just as uncertain then as it is today. And uncertainty is important, because uncertainty creates possibility. The people who lived 20,000 years ago could never have predicted our world. Likewise, we cannot predict the full reality of 20,000 years in the future. We can imagine, we can speculate, we can model. But the actual future will almost certainly surprise us. Because history always does. Nobody predicted the internet. Nobody predicted smartphones. Nobody predicted artificial intelligence in its current form. The future arrives in unexpected ways. And 20,000 years contains enough time for surprises beyond our imagination. Perhaps humanity changes completely. Perhaps it remains surprisingly recognizable. Perhaps some descendants look almost identical to us. Perhaps others are transformed beyond anything we would call human. Perhaps civilization spreads across every major region of the solar system. Perhaps it remains relatively small and scattered. Perhaps we discover life. Perhaps we remain alone. Perhaps we leave the solar system. Perhaps we stay. The possibilities are endless. But one thing seems increasingly likely. If humanity survives for another 20,000 years, we will no longer be a species of one world. Earth will remain our birthplace, our origin, the place where everything began, but it will no longer contain all of humanity. Our descendants will belong to many skies, many worlds, many civilizations, many futures. And maybe that is exactly what survival looks like. Not permanence, not stability, not remaining unchanged, but diversification, adaptation, resilience, the ability to continue despite distance and transformation. Because in the end, colonizing space is not really about conquering planets. It is not about flags, or resources, or prestige. It is about time. Buying time, creating redundancy, giving intelligence more opportunities to survive. The universe is ancient and dangerous. Stars explode, worlds change, civilizations collapse. Entropy waits patiently, No species lasts forever by accident. Survival must be built, maintained, protected. Perhaps that is what humanity ultimately becomes after 20,000 years in space. A civilization that learned patience, a civilization that learned continuity, a civilization that understood that survival is not measured in years or even centuries, but in epochs. And somewhere in that distant future, beneath a different sky and around another world, someone may still look upward and ask the same impossible questions that our ancestors once asked beside ancient fires. Who are we? Why are we here? What lies beyond? And maybe after 20,000 years of change, that simple act of looking into the darkness and wondering will still be the most human thing in the universe.